So this is a type of metabolic pathways. First with the instant energy, stored ATP and creating phosphate with 10 to 15 seconds. Then the short-term energy, anaerobic metabolism of glucose with 15 seconds to 2 to 3 minutes. Last is the long-term energy, aerobic metabolism, glucose and fatty acids and some with relative contribution depending on intensity. Anaerobic metabolism continues to contribute at higher intensities with 2 to 3 minutes and beyond. During the first few steps of exercise, your muscles are the first to respond to the change in activity level. Your lungs and heart do not react as quickly, and during those beginning steps, they can yet increase the delivery of oxygen. So this chart explain if we need oxygen in doing such physical activity or exercise. So in sprinting, it's not aerobic, meaning you don't consume energy because sprinting is considered as a very high intensity type of physical activity. Sometimes it's only 100 meters and only lasts for a second. Next is jogging. You think we need oxygen in jogging? Yes, we need an oxygen in jogging. Since jogging is a aerobic type of physical activity, for example, an athlete go for a run for 2 to 4 kilometers. So they need an oxygen to sustain their energy. So last is walking. So walking is a type of aerobic exercise that considered as to low to moderate type of intensity. So preferable is fat and same as jogging, they need oxygen. For example, when we do our daily activities, we need an oxygen. So what is metabolism? Metabolism refers to the whole sum of reactions that occur throughout the body within each cell and that provide the body with energy. By taking nutrients and substances that act as building blocks for movement, growth, development, and reproduction. So what is metabolic response? The metabolic response to exercise is indispensable to muscle contraction. The human body is provided with a sophisticated and complex neurohormonal system designed to guarantee proper fuel supply. The uptake of glucose from blood increases progressively during exercise, peaking after 60 to 90 minutes. Then, as exercise persists, free fatty acid concentrations in blood increase and the muscle gradually shifts over to burning more fatty acids and less glucose. What is ATP? Adenosine triphosphate or ATP molecule which provides energy for muscle fibers to contract the amount stored in the muscle is limited. ATP is critical for skeletal muscle contractile activity both in explosive power or sprint events lasting for seconds or minutes and in endurance events lasting for hours. ATP is required for the activity of key enzymes involved in membrane excitability, sacroplasmic reticulum, calcium handling, and neurofilament cross bridge. Because the intramuscular stores of ATP are relatively small, they are unable to sustain contractile activity for extended period. ATP is an organic compound consisting of phosphate groups, adenine, and the sugar ribose. This molecule is used during exercise and in several biochemical processes including breathing, heartbeat, cell repair, hormone activity, etc. What is aerobic metabolism? A chemical process in which oxygen is used to make energy from carbohydrates or sugar, also called aerobic respiration, cell respiration, and oxidative metabolism. What is anaerobic metabolism? Anaerobic metabolism is defined as ATP production without oxygen or in the absence of oxygen. occurs by direct phosphate transfer from phosphorylated intermediates such as glycolytic intermediates or creatine phosphate CRP to ADP forming ATP. Glucose may come from blood glucose, which is from dietary carbohydrates, liver glycogen, and glucose synthesis or muscle glycogen. Glucose is the primary energy source for both anaerobic and anaerobic metabolism. Fatty acids are stored as triglycerides in muscles, but about 90% of stored energy is found in adipose tissue. As low to moderate intensity exercise continues using aerobic metabolism, fatty acids become the predominant fuel source for exercising muscles. Although protein is not considered a major energy source, small amounts of amino acids are used while resting or doing an activity. The amount of amino acid used for energy metabolism increases if the total energy intake from your diet does not meet your nutrient needs or if you are involved in long endurance exercise. When amino acids are broken down and the nitrogen containing amino group is removed, the remaining carbon molecule can be broken down into ATP via aerobic metabolism, or it can be used to make glucose. When exercise, carbon molecule continues for many hours. Amino acid use will increase as an energy source and for glucose synthesis. You store a small amount of PC that you can quickly assess for bursts of high intensity effort. Think of your phosphagen system as your immediate energy system. It's the grab and go energy your body needs to jump off out of the way of an incoming train. In weightlifting, it's what you see used to achieve your 1 rep max, the highest amount of weight you can lift for one repetition. High intensity movements that last between 5 and 10 seconds use this immediate energy cycle. Your body doesn't have to go through the other two longer metabolic pathways. Because PC is stored in your muscles, it's immediately available to use. Anaerobic glycolysis breaks down sugar to fuel activity. Like PC, glycogen is stored in your muscles. After about 6 to 10 seconds of high intensity effort, your phosphagen system PC has run dry. So for intense activities and exercise that lasts longer from 1 to 3 minutes, your glycolytic system takes the lead. Think of the glycolytic system as your short-term energy system. Your body uses the oxidative pathway. Your body uses the oxidative pathway for anything that lasts longer than several minutes. After 3 to 5 minutes of intense energy use, it kicks in. The phosphagen and glycolytic systems are anaerobic, meaning they produce energy without using oxygen. Without the need for oxygen, they can kick into gear faster than aerobic system. The oxidative system fuels activities such as 30 minutes on an elliptical machine or running a 5K or even a marathon. A marathon runs at a lower intensity than a 100-meter sprinter does. While sprinters need a lot of energy, they run out of just as fast. But endurance athletes can reach a steady state where they can run at the same speed for miles. The aerobic system isn't as fast, but because the exercise is less intense, they're able to make energy at the same rate they use it and last longer.